Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video lecture, we are going to discuss about Generalized Hooke's law. So let us move ahead. What is Generalized Hooke's law? So the Generalized Hooke's law, we already dealt with Hooke's law in tension. We discussed that sigma x will be sigma is equals to E into epsilon, right? So, but in that case, we only said that if it is applied with sigma and it has E, then we said that sigma is equals to E into epsilon. So this epsilon is only the effect of this sigma, right? But when you also apply sigma from this side, then because of this sigma 2, there will be strain in axial direction, this axial direction, right? Because of the Poisson's ratio. Then so the total strain in axial direction will be this strain plus the strain produced by this, right? So we need to incorporate all these effects. So by incorporating all these effects, we say that this as a generalized Hooke's law. So let us move ahead. So let us take a 3D element. So in this 3D element, this is y direction, this is z direction, and this is x direction. Okay. So this can be said as by principle of superposition. Sigma y sigma x, right? Sigma z. Sum of these three things, right? So let us move ahead. Suppose this is net epsilon x due to all these three stresses, epsilon y net and epsilon z net. Okay, right? So first let us apply in x direction. This is sigma x, this is sigma x. Then what will be the axial strain produced by sigma x in axial direction? That will be sigma x divided by E, right? Then what will be the strain produced by sigma x in y direction? That is given by Poisson's ratio is equals to minus epsilon dash by epsilon. So this epsilon is sigma x by E. So we get epsilon dash is equals to minus sigma x by E into mu. So mu minus sigma x epsilon by E. Similarly in z direction also minus mu into sigma x divided by E, right? Now in y direction, sigma y, then epsilon y will be sigma y divided by E. Now here it will be sigma y divided by E, right? This will be similarly sigma y divided by E. Now because of the z, sigma z, then it will be sigma z divided by E. So this is the concept for all parts. Okay. So sigma z divided by E. This will be minus sigma z divided by E into mu minus mu into sigma z divided by E. Right. So what is the combined effect? The combined effect is sigma y, sigma x, okay, and sigma z. The combined effect net y net. So let us add all these three things. Plus, right? Plus. Okay. So you get here sigma x divided by E minus sigma nu sigma y divided by E minus mu sigma z divided by E, right? Now it will be sigma y divided by E minus, right, mu sigma x divided by E minus mu sigma z divided by E. You add those three terms from previous slide. So this will be similarly sigma z divided by E minus mu sigma x divided by E minus mu sigma y divided by E. So this is net epsilon x, means net strain. This is net strain in y direction. This is net strain in z direction due to all these three stresses. Okay, due to all these three stresses. Okay, this is the combined effect. So this is generalized Hooke's law in actually in tension, right? Similarly, there should be generalized Hooke's law in shear. So in shear case, that is simple. In shear case, it will be tau xy will be is equals to z into gamma xy. Okay, so yz is equals to z into gamma yz. So zx is equals to 3 into gamma zx. Because these three things are independent to each other. In case of shear stress, but in case of axial loading, these things are dependent on each other because of the Poisson's ratio. But in this case, there is no Poisson's ratio kind of thing, so there will be no dependency between these three things. Okay, with this we end today's lecture. We come with, in next lecture we are going to discuss about elastic constants, that is E, G, K and nu and their relationships. Until then, take care. Bye bye from 9 point.